Okay. There we go. There goes the input filter. I knew it would happen eventually. You got magic smoke. Oh my god, that stinks. Let's look at this HP 8165A Programmable Signal Source 1 MHz to 50 MHz. So it's basically a waveform generator. Does sine, square, triangle waves. If you've got the right options, you can also have a sweep on it as well. I think it's got option 2, you can do a sweep, but don't remember if this one's got the option or not. So I purchased this as a non-working unit from eBay. It was shown in the pictures having power, but not working. I originally powered up when I first got it and it was dead. I'm going to try powering up again now. I've already got it running. So I'll turn the 30 volts going into it. So we'll try pushing the power switch and see what happens. It might go bang, it might not, it might do nothing at all. Last time I tried it, it did nothing at all. So let's give it a go. Nothing at all. Not even a fan. I was looking at the circuit diagram just now for this thing, and the fact there's no fan is probably a good sign. It means it's probably just blown the fuse out for some reason. Could have been inrush current. Maybe it's bad capacitors cause a high inrush current. Maybe they started shorting out or something. Could be something like that. We'll try replacing the fuse, or at least checking the fuse and see what happens. So I'm going to pop this fuse out. Now what I did previously is I changed the switches here. So originally it was on 120 volts, which is down there. So all I've actually done when I got this thing is I got that switch and shoved it up here, like that, to make it 240 volts, because that's what was required, because this one's already in the right position. I believe, was it 220, 120, 220 volts, I don't know. Anyway, wherever it was. So this is the fuse, let's get this out. And that looks intact. But don't let looks deceive you. Always check. Just because it looks intact doesn't mean it actually is. Well, it is intact. I've actually had fuses before which have looked okay in the centre, but have actually failed right at the very end. So the end of the actual fuse filament, where it goes into the in cap, must have been where it had gone, because the rest of it looked absolutely fine. Anyway, the fuse is intact, which makes things a little bit more interesting, because there's not much to this part which will stop the fan from running. Might have to open it up and find out. Anyway, we'll plug the power back in again now and just retest it in case maybe it's our switches which are blown up. Looks like that switch. So nothing still dead. Let's pull these covers off and then start digging into it. So what I'm going to do is a nice little trick, which is to measure across the IEC connector with the power switch turned on, see if you can see the transformer. Because if you can't see the transformer, then something else is going on. So let's try that. And we're getting a pretty high resistance there. 50 meg. That ain't right, is it? Change the switch back down to its original position. 38 meg. Change out the switch. Must make sure I don't forget to put these back. 37 meg. And put that one up there. Let's see the combination then. In the 120 volt range is 10 ohms, so 11 ohms, which sounds more like it. So it could just be the switches, or it could be there's a bad coil. Let's just work the switch, see if it does anything. It may need internal cleaning. It's changed. It's now 20 meg. So there's definitely something going on here. Yeah, still sort of 20 meg. So it could even be there's a bad transformer winding. It's possible. Seeing as it switches did something. Let's check that part of it out. Let's get the top cover off. Let's flip it over. And there's cobwebs and stuff in this side here. Look at those boards. Look at that. All that gold. Wow. There's a lot of gold in there. It could be gold plate, but it's also possible it's got a yellow solder mask, which is in on the copper, which makes it look like it's gold. I don't know. It could be gold plate. It's entirely possible. These things weren't cheap. So they've got some big caps in this area. I'm not going to touch anything here because it's been powered up, and it's entirely likely that it's got some kind of charge in there, even though it didn't have anything showing up. It's possible. Up in here I can see a Rifa cap off the fuse holder. But yeah, lots of cobwebs. Hopefully there's no spiders in there too, because you know, could do without any imported spiders. And right down the bottom here on the front panel, you probably can't really see, if I get it just right maybe, right at the bottom edge down there, there's 2 batteries. And there's a couple of Defpoms here as well. And this is a cartridge. There's a lever here which is broken lever. There you go, up there. So I designed a replacement lever some time ago when I was working on another piece of HP gear, so I can 3D print another one. I'm just having a bit of a look around so we can see anything which looks obviously bad. Nothing's really showing up. Well, we've got to get to this back panel here, so let's take this panel here off I think. It's also helping hold the cards in, but I can see at least one Rifa cap. There's the input filter. You will see the back of the switches. So those switches are like plain switches. If I can get to the back of the switches okay, I could actually measure directly off the back of the switches to the transformer windings to make sure the windings look okay on the back of the switches, comparing against the circuit diagrams to make sure I get the right ones. Alright, let's just test across these switches here. So I've got to test from the common on one side of the switch to the common on the other side of the switch, well, the 2 switches. That will check one winding. This is in the 240 volt setting. So if I test from the furthest terminals apart, that will also check the switch as well. We'll check one of the switches. So getting 6 ohms across that winding, and it's also going through the switch. In theory, I'll double check across the other one as well, just to make sure I go both sides of the common. Aha, there we go. So that is wrong. So that's 39 meg or so, 37 meg, and that switch is in the upper position, so I should be able to go across these 2 commons right here, and that should be a short basically, and it's not. It's meg ohms. So yeah, the switch is the problem here. That's great, in a way. Now the thing is, I could easily bypass the switch and not use it at all and just forget about it, but then there's potential that if I ever sell this and it goes overseas, someone tries to change the voltages on it, it could be a bit of a disaster for them, so I need to sort of consider that aspect of it. I'm also doing a live stream for the people which are watching this later on, and the J1 car which I said I was concerned about, apparently that is the option 2 for the AM sweep thing, so that's not a concern. So if you don't catch my live streams, do try and catch them in the future. So this was a switch problem in this case, at least to get the power working. And I'm sure this isn't the only problem it's got. So I could just try flushing that switch with some cleaner and see if it comes right. Ideally I'd replace the switches, but that would be a bit tricky in this particular case, trying to get some which are the same. So I'm going to flush it with cleaner. There's some holes in the back of the actual switch. I'll stick it face down, back down, so I'm going to put it on the rear, and get some cleaner in there, and I'll try and wiggle them around and see if it comes right. So after giving these switches a clean, it's got the screwdriver here, and just basically did that with the deoxit in there. Alright, sprayed deoxit into the back of the switches, and I'm now getting 14 ohms, 13 to 14 ohms across there. So that's looking more promising. Now what I should probably do is give this a chance to flash off, because it could be that there's a slight arc inside the switch as well. It's dropping down in resistance gradually, it's gradually getting better and better. If I power this up right now and there's any arcing in those switches, it could well go bang. So I'm going to give us a chance to actually flash off a bit and get rid of all the solvents and stuff out of it. Of course I could always flash it with IPA as well. It's not that these switches get used much, they're just set and forgotten, so right now I've got deoxit everywhere, I need to clean it off. Right, so after cleaning our switches out, I'm going to power this up for the first time. It may go bang, there might be magic smoke, there might be an explosion from all the deoxit, I don't know. But as soon as I flick the switch, something bad could happen. In fact, I'll turn this power switch off on the front. Okay, nothing so far. There shouldn't be because the switch is off on the front. But when I turn the switch on the front, something could happen. Yeah, that's really bad. We have power and have a fan. Excellent. That's the first stage. We've got the thing to power up now. So let's repower it and see if they get the same fault again on these displays, on these buttons. And now we're getting error showing up. So yes, there's definitely something going on. Before it didn't show error. Let's give it a longer power down time just in case this wasn't powered down properly enough. Bit of reset time, and then we'll try it again. So now we get error showing up. Okay, and you got the middle display on now. So it's different. Excellent. It had something wrong. So I'm going to reset these cards, because that always seems like a good idea, if I can get the things out. That's super tight, which always worries me a little bit. That is really stuck in there really hard. That does not want to move. I don't want to put on the lever because it might break the lever off. Wow, that is really stuck in there. I do super glue it. Let's try the next card. No, that doesn't want to come out either. Try the next one. No. And no. These are all super tight. Let's just try this one. It's on a subboard, and that doesn't want to move either. So these connectors are really locked on. So you've got this front panel board as well. I'm just wondering about pulling the front panel board out. It's got a bunch of ribbon cables and stuff in there. A couple of batteries on there, as I said before. I might actually pull that board out, do the electrolytics on that one, put that one back in again and say that one's done. Because it's likely a power supply problem. So if I can find these test points, which I think I just have, down here, there's some test points on the board, marking the voltages. Ground reference, I'm guessing. I have to be careful about that. But I could check the ripple on those test points down there and see what's going on with those. Test points are right there. Voltages. The main plane of the board will be ground because these are shielded cables and they're attached to the main plane. So I'm guessing I can connect to that as a reference. It's a Phillips cap, that's bound to be bad. Phillips caps always go bad when they get this old. As far as electrolytics and stuff goes, it's actually not looking too bad. There's actually not that many in there, which is good. It means there's not much to replace. And there's only a few on this main board over here. Yeah, it's looking promising. They've got some massive ones here, which would be a problem if I had to replace these. And that's the main regulator section down there. It's got a couple of big resistors down there. So capacitors this big usually don't go that badly. Oh, there's another one down the front there, the front edge. I think I need to get these boards out, but they seem to be locked in place. I can't get the bloody thing to move. And it is just the connectors. I just want to reseat the things, because that could be something which resolves the problems. Even though they're gold plated, sometimes just take them out and reseat them a couple of times and it comes right. There's a custom IC up here as well, HP part, 18260389. So this board has some residue built up over here, some kind of debris on it. I'm not quite sure what it was. It's a little bit crusty, so I'm just going to clean this board because it's right next to the vents on this side, so it could be something's dropped in it at some point. So I'm just going to give this a bit of a clean up with this, bit of IPA, and just try and get anything off that might be sitting here. There's definitely some stuff on it, some kind of granules sort of thing. So that could be part of the problem, some residue on this board which is causing kinds of issues with the digital electronics. And there is definitely some tarnishing on these gold connections on these edge boards, connectors, board edge connectors, get the right word. Gives a flush. So at least we have found something. Looks like a factory bodges here too. There's like two pins which are linked together with a piece of wire. It's certainly looking a lot cleaner. Just rubbing this board edge connector to try and get any residue off it. It does have a little bit of tarnishing on there. Put some more deoxit on there again. Problem with deoxit is it tends to put either nothing or way too much. Seems to be the way it's designed. There we go. I'm getting a slot. Even when I'm moving this thing around, it can hit like crunching. I don't know if there's anything in that socket. Because when I was pulling it out, I could hear it sort of crunching. Let's power it up again, see what happens. Let's power it up and see if it goes bang. I think all the cards are in probably. So I just pulled all these cards out. I should actually cover this video, didn't I? Did I record that? I can't remember. Pulled all these cards out, cleaned the edges up. This backboard had all the dirt on there which I've cleaned off, and hopefully it will work. Still got error flashing. Didn't fix that problem. But there could well be power supply problems. But at least I know those cards are done. There's still a few others I could do. Well, let's check these batteries out and see if there's any voltage left in these things. So this is the front panel board. Well, the one behind the front panel. See if we've got anything left in here. 0.87 volts. This one here is 0.4 volts. HP part number 1420 something. I'm not sure what voltage is supposed to be. 1989 is original, most likely. Both dated October 89. Sanyo 1N100 AAS. So if it's got any memory functions, that could be a problem. If it's got calibration information, that could be a problem. Maybe that's what the error means, that these batteries are flat. It's lost calibration. It's entirely possible. And there's a few capacitors on this board as well. And because of how much of a pain it is to get that board out, I'm tempted to just replace them now. But then I've got these battery issues. I don't have any batteries this size, I don't think. Flashing error indicates incompatible operating modes or parameters. Yes, okay. There we go. There goes the input filter. I knew it would happen eventually. You got magic smoke. Oh my god, that stinks. Open the window a bit further. Woo! Well, there's your magic smoke, guys. Yeah, that's fun. I'm pretty sure it's the input filter. Let's have a look. This is what I should have been recording. I wasn't recording with the other camera. Oh no, it was the Rifa. That was the Rifa cap blowing up. The Rifa's gone. That's what that was. Yep, it is the Rifa cap. Didn't smell quite right. The input filters smell different to that. See, I told you I have to change it. That's why. Didn't go straight away, but it go. So let's try turning it off back on again. Well, I probably could power it back up again now, it'd be alright. It's blown now. The input filters smell different to the Rifa caps. Yeah, I was thinking, that's not input filter, because it didn't smell quite right. Wasn't as acrid. So I've got my little extractor fan going now down there and window wide open. Hopefully the smell goes away soon. It's pretty yuck. So the Rifa cap in the back here, which I was suspicious about, blew up. So here's what's left of it. I'll cut it out. And sure enough, it exploded. Big cloud of smoke and stuff like that. Unfortunately, I didn't catch it on this camera because I wasn't recording at the time. But as I was live streaming, it's on my live stream, about 3 hours or so, around there somewhere. Yeah, if you want to catch it on the live stream on this thing, then you might see it blow up. But this is why you replace Rifa caps, because they go bang and make lots of smoke and smell bad. So I'm testing the output now. I've just replaced that capacitor. It's got the new one in there now. Hasn't blown up yet, so that's a good sign. I've got the output hooked up to my oscilloscope up here. I'm outputting 1 volt. And I'm supposed to be doing a sine wave, and I'm not doing a sine wave. It looks more like a ramp. So I'll do a triangle wave, and then a square wave. Yeah, 50% duty cycle, apparently, but it's not doing that. So it's got a few things going on which aren't right. A lot of the controls seem to be okay. Frequency wise, that's saying it's 2.7 kilohertz. But the sine wave again, it's also a triangle, which isn't right. So if I just try changing the frequency again, let's try 0.1 megahertz. Now we have an offset here. Right now I've got a DC offset. Offset is 0 volts. There's no offset currently set. So that shouldn't be an offset there. And that's not a sine wave. And that's saying 73 hertz, which isn't 100 kilohertz. So that's not right. Triangle wave, which looks more like a ramp, and square wave is not. We'll change duty cycles. So 50% duty cycle is definitely not right. That's not 50%. I'll do 80%. That's looking closer to 50%, although it's slightly the other way. 20% is, yeah, pulsing. So yeah, those are not right. So it's definitely got some issues going on here. It's going to take some fun to figure this one out. So 1 megahertz, I'm getting this ramp kind of triangle wave on the sine wave. So that's doing 1 millihertz, I think. So let's do kilohertz. So 1 kilohertz shown up over here, and amplitude 1 volt, offset 0, running on VCO, on sine wave, and the output from the scope is looking different. See, this is not 1 kilohertz. That's not 1 hertz. If I do 10 kilohertz, I'm getting about 10 hertz. 100 kilohertz. This is interesting. It says 100 kilohertz. I'm getting about 70 hertz. That's very curious. So if I do 10 megahertz, frequency 10 megahertz, which is that one, what do I get then? I'm getting about 2.5 kilohertz. And it's not even showing that up there either, that megahertz symbol. Which I thought the megahertz symbol would be going. Maybe it's got a blown LED, maybe that's why the megahertz isn't working. Frequency hertz. So it's 10 hertz there. I'm getting it as a DC offset. Frequency millihertz, that lights up. Frequency kilohertz, so it's 10 kilohertz. That is not doing 10 kilohertz. Frequency megahertz, megahertz symbol is not lining up. So that's probably a blown LED or some kind of control line signal problem. But it's only doing 2.5 kilohertz. So that's not right. Frequency 50 kilohertz, or sorry, 50 megahertz is most it's supposed to do. That's 1.6 kilohertz. Yeah, so that is definitely not working right. Excellent. So when I was checking these batteries before, I didn't notice something which I should have probably noticed. The top terminal on both batteries are the positive and actually in series together. So if I take the top battery here, getting about 0.9 volts. These are NiCad batteries, 1.2 volt batteries, so it's not great. This bottom one here is minus 0.4 volts. This one's swap polarity. So this battery is definitely dead. This one might be survivable, but they're just wired up in series together. So I can actually replace this with a 2.4 volt pack and just take those two individual batteries out. It seems to be like some kind of RAM backup thing. I'm not quite sure what the RAM is actually affected by. I'm not sure if it's just settings, like last year's settings or whatever. I don't really actually know. It might be that. But these batteries are knackered, so they need replacing. So I just happen to have this battery here, which is for it's a BT694 battery, which is 2.4 volts. It's not a NiCad, it's a nickel metal hydride, but that shouldn't matter. I imagine it will charge up and be okay. I'm tempted to put this in. Same voltage, I could just take those batteries out and just put these wire leads onto those two terminals and strap it in place, and that would be done. This is actually for a cordless telephone, but I don't care about that. Sounds like a plan to me. Otherwise I've got these other ones which are 3.6 volt packs. I'm going to keep them with something else. I've got this other old pack here which looks like it's probably been leaking, it's all crystallised. I think I'll just chuck this out. It's been sitting in the bottom of my drawer for I don't know how many years. I think that pack's going to be bad as well. But these are NiCads, so they actually do like batteries, but they're obviously much bigger. I could pull that pack apart and see if there's any life in it before I throw it away. So I pulled this pack open, it's pretty bad shape, all the cells are dead, so that's definitely going in the bin. So I'm going to be using this one. Right, so let's get these batteries out. First thing I'm going to do is cut these straps that are holding them in. They're not needed anymore. And I should unsolder the terminals and I fall out. I mean, the RAM is definitely gone anyway, because say they're in opposite polarity, so it's only going to do like half a volt across there, so any RAM contents likely gone anyway. I'll be surprised if there's anything left, so I think I should just take them out and just hope for the best. Right, so what I'll do is just wedge a tweezer in underneath, like that, and desolder it. There you go, that's one. Now I can hold it with a tweezer. Hopefully, here we go. There's one battery out. And there's the other one. Okay. So normally you wouldn't do that. You would make sure you've got a supply across the batteries so they don't go dead and that sort of stuff. So you would normally be a lot more careful about that. But in this case, that's not what I'm doing. Just in case it's a different version, let me just double check this before I shove a battery across it and potentially short it out. So let's make sure. So there to there, not connected. There to there should be. They are. There to there are not. There to there are not. So yeah, it's fine, it's in series. That looks like it matches the circuit diagram at least. So I'll cut the plug off. Now I'm just going to put some solder on these wires. We'll give them a bit of a twist already. And they will just reach the existing terminals, which is great. So don't forget, I'm not going to be using the middle terminals anymore. I'm going to be using the end terminals because those two batteries are in series anyway. So let's hook this up. Where's my tweezers gone? Here they are. Be careful not to short the batteries out because that would be bad. So I might put the positive terminal on first though. Get that one out of the way so it's not floating. Right, that's the positive terminal on. This is going to sit in here. It's got this wire there. I'm not quite sure which way I'm going to put this battery yet. I'll try and use the original cable tie mounts if I can, and maybe stick it like that. I think that would work. Okay, let's get this bottom wire on. Okay, so that's the wire then. So it should now be good for battery. Now I need to actually mount it, as I say. I need to figure out which orientation I'm going to use. So I kind of want it to go like that, I think. I think that'll do. So there you go, so the battery's mounted up. And I've also put some of my liquid electrical tape over there as well, along this edge, just to help secure it in case the cable tie gives way, or just it will be held in place. And also done the wire ends to stop them from potentially coming off and breaking off with movement. And just here as well, this stuff's still wet, so it's still going off. Just so it's held in place so it can't possibly get trapped between the cover and the edge of that board or anything like that, because that would also be bad. So that's that bit done at least, so we should now have a backup battery. Alright, so now I've replaced that battery, I've powered it up. You can see I've got frequency set mode, so 10 megahertz. So the megahertz symbol isn't showing up, so I think it's got a blown LED there. I need to figure that part out. It's probably a blown LED, it could be something else. But everything else seems to work. If I do millihertz or hertz or kilohertz, that's all functioning. Just the megahertz one isn't lighting up, so yeah. So I've done all that stuff now. I'm going to hook up the scope again to the output, just check the outputs again, see if everything's behaving a bit differently now I've done that replacement battery. Now the theory is that now I've done this, I believe it will now retain the settings in between power cycles, which it wasn't doing before. So I've got set 1 volt right now, 1 megahertz, sine wave, normal mode. We'll power it down, leave it down for a while whilst I hook up the scope, and we'll see if it comes back with the right settings. Right, so I've got the scope hooked up. Let's power it up again, see what happens. Now, what happened previously, if I'd done a power cycle, it would come up with an error status, which is potentially due to bad settings, because the RAM was being corrupted because it wasn't being held at the correct voltage, so it's losing data, I'm guessing. So I'm hoping that now it will come back on again with the same settings we left it with, or at least not have an error. Let's see if it does the trick. Same settings, no error. Excellent. That did the trick. So let's fix that problem. So let's actually look at the scope once I get the output working, and we shall see what's going on there. So that's what we're getting straight away. So I've got to set the sine wave, 1 megahertz, 1 volt. I'm getting 1 megahertz basically. It's very slightly off frequency, and the voltage is not 1 volt. So I'm 50 ohm output. Right, so I should be doing 1 volt, but it's not, which is interesting. So if I go to the triangle wave, that is doing 590 millivolts RMS, 2 volts peak to peak. Let's go back here. I should look to peak to peak actually. What's peak to peak? And that one is 440 millivolts. So sine wave isn't looking right. Okay, triangle wave is looking closer. Don't forget this is based on 50 ohm load. I'm not 50 ohm loading it, so therefore the voltage is going to be double. So that should be 1 volt if I was loading it correctly, which I'm not. Let me load it with a 50 ohm load, then we can at least rule that part out. So now we've got 50 ohm load across there, and we're getting 1 volt, as you can see, right? Hopefully you can see just down here, 1 volt peak to peak. So I'll do sine wave now. It's definitely way less than that, and it's not doing a nice sine wave either. Square wave, lots of ringing. That's probably because of my cable and all this stuff. It's not perfect probing, but that's doing basically 2 volts because of all the ringing. So if you look at the main waveform here, it's 500 millivolts per division, so that is actually 1 volt peak to peak, apart from the ringing. There could be this unit, it could be the cabling setup I've got here, even though I've got a load on there. Let's turn the bandwidth down, bandwidth limit off, 1.2 volts, because I've still got a bit of ringing in there. Okay, so that is working. Back to sine wave, that is not right. 1 megahertz sine wave isn't working properly, at least the levels are incorrect. So let's change the frequency. Let's do 10 kilohertz. It's got a DC offset now, see that? I'll do horizontal time base. Do that. And so we've now got a DC offset. That's not a sine wave, is it? It's a wave, more like an ocean wave than a sine wave. And there's a triangle wave again, at 10 kilohertz. That frequency is correct. But this sine wave output is giving us some trouble. So that's going to require some further investigation because it's got a DC offset and it's wrong. I did check the power supplies. I've gone back through, checked the ripple on these because I wasn't sure about the ripple before. And once I had all my gear turned off and things like that, my noise levels got a lot quieter and I could actually measure less than 5 millivolts peak to peak noise on the power supply rails. So those all seem fine. And I've also checked all the capacitors, and there's one I was suspicious about. I replaced it and it didn't actually change anything, it was fine. So once I got the thing out of circuit, it looked alright anyway. Let's do square wave with a 20% duty cycle, 80%, about 50%. But the sine wave is definitely very wrong. At least the triangle wave is centered around a 0 point, as is the square wave. So I know it's the sine wave side which has got the issue here. So if I go even lower in frequency, let's do 100 Hz, shall we? And now we have what looks like a sine wave, and it's centered around a 0 point. So at very low frequency it's fine. Now we can do vernier frequency control. It would be nice to find out where it changes. You might find there's a point where it suddenly shifts, which might give us a clue about where to look. So that's 450 Hz right now. You can see the top corner of the scope. Let's keep on going up, and hopefully we find where it fails. There we go. Jump down. So up to 1 kilohertz, it's fine. As soon as you get to 1 kilohertz, it fails. So let's keep on going up, see if it comes back again. They might give me a particular circuit section which is something I need to look at. So at 4 kilohertz now, this could take a while. 20 kilohertz. It's 50 kilohertz. It's almost 100. But the level's getting lower and lower, which is also very interesting. Because you're not supposed to be doing 1 volt output. Obviously with the 50 ohm load across it. It's about 600 kilohertz there. Would be nice to find a point where it comes back. There we go, it's come back. So where was that? That is at 1 megahertz, interestingly. But it's giving us a triangle wave. So yes, it's kind of back, but it's wrong. So let's keep going up. It's now 3 megahertz. 5. I can see distortion starting to appear now as well. There's 10 megahertz there, well 13 megahertz now. And it's starting to come back, look at that. It's 32 megahertz, it's starting to come back. That looks like a sine wave again. So I'm going to find a point where it starts to change. There's distortion there, it's 20 megahertz. And distortion is almost gone there, and that's about 27 megahertz. And now the amplitude's coming back as well. and then come back down again. That's at 46 megahertz, and there's the maximum of 50. But there's a lot of jitter on here. Yeah, there we go. So 1 kilohertz was that point where it fails, and I heard a little relay click just then too. There's a relay clicking, so it could be a bad relay even. You never know. So I'm just hooked up to TP7 on the A5 board here, which is not actually marked, it's right next to one of the read relays. And this relay switches the output from the high frequency source to the low frequency source. And right now I'm on the low frequency source. The yellow waveform is the output from the generator, and the pink triangle wave is the waveform at TP7, which is before it goes through the sine wave shaper. So I'm just trying to determine whether it's before or after the sine wave shaper where this issue is happening. Now obviously it's going through the sine wave shaper absolutely fine at this frequency, which you can see is 999 Hertz. If I go up to 1 kilohertz, then it changes, and both waveforms change, and you can see that it's basically a triangle wave coming through with the sine wave, and the amplitude drops down considerably. So I think that is related to what's going on here. As though that waveform that's coming in is just basically being lost, and so the wave shaper can't do anything with it. Right? So you got like a sine wave on the bottom, but the top is now a peak. So I think there's something to do with this section here, where it's not actually switching to the correct one. Could be a bad relay. Read relays do fail, they do get old and fail. It could be that. It's entirely possible because it's got a op amp which is doing a feedback, and it could be that op amp has failed as well. But this is some level of progress that I'm seeing this which matches. The shaping disappears and the amplitude of the triangle wave disappears, and that's at TP7, so I know it's before the sine wave shaping that something's going on, because that amplitude shouldn't drop right down like that, and that's probably related. Right, so I'm probing on pin 1 of K301, which is the high frequency input, which is supposed to go through it. Now this frequency here, 999 Hertz, is doing 10 megahertz. If I go to 1 kilohertz, it changes quite a lot, as it should. Now it's doing 1 kilohertz. Okay, so that's doing 1 kilohertz there. Now that level is fine, that's looking about right. If I come over to a different pin, I have to use some weird probing techniques there to get in there. So here is pin 8 of the relay, which is the output. There's low frequency, there's high frequency. As you see, it's dropping down, and it's not supposed to drop down because that should be the same level as it is on pin 1. It's not, because it's going through the read relay. So the relay is either not turning on, or it's really stuck or something like that, or it's got a bad connection. So I'm going to have to figure that bit out. But something's still wrong here. So let's test this read relay, see what's going on here. So I've currently got it on the low frequency range. So it should be linking pin 8 to pin 14. So I'm going to measure across there now. 0.2829 ohms. That seems fine. I'll put the probes together themselves. Not the best connection, but it's similar. Okay. So if I do between pin 1 and pin 8 instead, there should be the connection for the high frequency range. So there should be nothing right now, it should be completely open. And if I go to the high frequency by shunting up, I need to be over here. And look at that, 4 mega ohm. That's open circuit. That should be shut. The relay is energizing, but it's not closing the contacts on that second pair of terminals. So it needs a new read relay. I just thought I'd show you this. So as you can see right now, the waveforms coming out of it are bad. It's got a DC offset and stuff like that. I've got it set 1 volts and 500 millivolts for division right now, so it's a big offset there. So if I stick the probes across the read relay's coil, got nothing there right now, that's not turned on. That's as it should be. If I took the frequency down to say 1 Hertz, see it's all bouncing around now. Stick that across the coil, and we now have 4.6 volts. So the read relay is definitely being energized, we know that, so that's okay. Now there's a little trick I've also found. Now Anything below 1 kilohertz is working, we know that. But I want to find out what happens when we go above 1 kilohertz, and I basically hack it. So let's stick this back at frequency 909 Hz. That's working absolutely fine. You can see the waveforms there, just about see those in the distance there. What I'm going to do, and it's working fine, so if I go up in frequency a little bit from that, that's when it falls over, that's at 1 kilohertz. If I do some crafty probing here, and if I probe across the read relay using current mode, like that, you can see it comes back. So 1 kilohertz, that is now working. And it's if I'm shorting across the read relay myself to replace a read relay which is obviously not shutting properly. So if I change the frequency again, say it's really bad at higher frequencies, right? So let's do 999 kilohertz. So 1 megahertz or so around there is being particularly troublesome. It's got the offsets here, it goes a bit weird and wacky and it sort of drifts around a bit, as you can see up there. If I wind this frequency up, it pretty much kind of comes back, but it's never right. The levels are wrong, it's not quite. Right, if I wind up the time base, now they're actually overlaid each other, right, so they're both there, but the levels are completely wrong. Okay, so that's kind of working. Frequency is 3.2, which is correct. So it's there, but it's really low level. That's wrong. So the offset's gone away, but the waveform is now triangular. Right, that's what we're getting. It's basically like a triangle wave on a sine wave setting, and it's distorted. So that's completely wrong. Bring it back down. Let's short across the read relay again. There we go. So the level comes back, and the waveform looks a bit better. So that's more like what we're expecting. So it's not right still, but it's better. And that is at 4 megahertz. So if I do something like go up to say 30 megahertz, just do that. 30 megahertz. Same kind of deal there. It does kind of come back though. But again, really distorted, not very nice. Probe across the read relay again. And it's back and it's looking like it's supposed to. Right, that actually looking really nice there. Whereas that medium frequency around sort of, you know, that one we showed just now, 4 megahertz, is not looking right. It looks distorted. So it could still be that once I replace that relay, there may still be a secondary fault still there. But at least I identified that the relay is bad. So let's do 50 megahertz. See, there's lots of jitter in there as well, 50 megahertz. There you go. It's looking much nicer. So, replacing that relay should fix it. Now, the interesting thing is that with relays and switches and anything which has got a bad connection, it's trying to be there, but it's acting like a capacitor, right? Because it's not actually, it'll be shut, contacts will be shut, but it'll be dirty or arced or something, and so they are acting like a really thin film capacitor. These capacitors, they act differently with frequency, right? Most people know this already. So as you wind up and down frequencies on this thing, you get more and more activity on here. That's the 200 millivolts of vision right now. So that's reading 400 millivolts RMS, 1.1 volts peak to peak right now with a 5 volt output setting. So if I go through the frequencies downwards, you watch what happens to it. I'm just going to scroll through. You see it's getting smaller and smaller. Now that is an effect of the contact capacitance. So you look how distorted that is now. It's like a triangle wave, just distorted. That's at not 10 megahertz. We keep going down. Right, but it got smaller and smaller, and they're sort of plateaued there. Now it's coming back a little bit, and it's also got some other effects going on there. Can't see it too well, I don't think, on the camera, but yeah, the Now it's getting bigger. It's coming back again. There we go. Now it's dropped off. That's at in the kilohertz range, and now it's dropped right off and disappeared. That's got that big offset on there. So we can see 999 hertz again. So it's back. And that's the full size waveform like that. So yes, it's not right, but now we know that fixing the relay should fix most of the fault, I think. The other thing we've got going on here is this indicator which isn't coming on, so I actually need to check onto that as well to find out what the story is there. So whilst it's got a kilohertz indicator on, I'm going to measure the back of that and see what voltage we're getting. I think it should be around 5 volts or so. Based on what I can see on the diagrams, it should be about that, I think. And these are actually bulbs, not LEDs. They're sandwiched in between the PCB and the front panel. 4.5 volts. So let's go to the megahertz one. We'll go to that range. So that's the one which isn't lighting up. Measure on the back of that. So that's 4.7 volts there. So I need to get some kind of indicator which will run at 4.5 to 4.7 volts to replace that bulb. That's only a minor repair, hopefully. Depends how hard it is to get the front panel apart. So I thought I'd check these other indicators as well, and I just went down from volts down to millivolts, and it's not lighting up. So it looks like that indicator's gone as well. So it does 10 millivolts up to, I think it's 10 volts, I think was the maximum. I could be wrong. But yeah, so the millivolt indicator's not lighting up either. The 90 volt range is working. 10 volts maximum. Yes, we got an issue there too. That's alright. So since I replaced those batteries, I haven't had any problems with this thing giving errors on boot up. It's always using the last used settings, so whatever settings I last used on it, when I power it up, they're loaded. So obviously that is working correctly now. That is no longer an issue. So I'm happy about that.